So here is a problem that we have with frames. They have too many elements, and that could be overwhelming because we need to find low internal loadings in these elements, and there are um, we find difficult to solve for them. Here, for example, in this one case that you can see in this frame, the problem is asking to find the stress in this wire cable that we have between C and F, and another one right here between this element B and D. Uh, and that basically resolve when we look at these relationships by definition to finding the internal loadings in those two elements. And there are the easiest way to deal with frames is to start thinking and looking about, of course, related to those elements that we are interested in, to start using thinking in free body diagrams. What can I isolate? And we can use any one of them. Do isolate every element that we have, or multiple elements, as we are doing it right here. We are isolating from the frame three elements at the time, and that helps. For example, here in the first free body diagram, we can see that just taking this CE element there of the frame, then we are, when we do isolate it, we have all of these support reactions, and we also have that internal loadings. In this case, we have both of them. If we isolated that, both the internal loading in this BD element and in the cable CF that we are seeing it there. So when we look at this right now and we think this moment, if we are able to do some moments about this point C, then all of these unknowns that are there disappear from that equation, and we end up with only one unknown, FBD, and we can solve for it. In the second diagram, the same way as we said, we isolate several elements in here, and again, when we look at the support reactions, right, then we have two here. At this moment, if we are taking the sum of moments about this point A, then we end up finding having only one unknown, and that will be FCF. That acts in the second element that we didn't discover yet. So we can see that using the different free body diagrams, thinking in them before you draw them, you can think, look at where what support reaction you have in these elements, and then what are the possibilities there, because that helps. And uh, never consider yourself that you should not isolate one or two elements at a time of the frame, or multiple elements if needed. So of course, right now, after from this free body diagram that we have here, as we said, we take the sum of moments about point MC, and it's quite easy to solve for it. We have a 45-degree angle because this is a this portion is zero point 0.6 meters, the other one is 0.6 meters, so that's the angle 45, so we can solve for it easily. And in the second free body diagram, sum of moments about point A. Again, in this case, we have a sine of 30 degrees. That is the one that does create the moment here, that component, and then again we can solve for it. And as I mentioned in a previous video, just leave as especially if it is like here is diameters, we will deal with diameters in many places, leave them as millimeters and use the radius instead of the diameter, because most of the time you can just simply divide by 2 the diameter, get the radius, and that simplifies your work in calculations in arithmetics there. So, and if you leave millimeters, then also further simplifies the work because you end up with megapascal. So this very simple problem, you can see, solves an overwhelming situation that we can have at the start of the problem. So I hope this helped, and I hope you have a beautiful day.